Hi guys, my name is Harry. I'm very glad to introduce myself as an IB tutor on GuruMe. Having done IB myself at high school and biochemistry at university, I have been teaching IB biology and chemistry for 5 years now. I'm about to introduce you to my IB chemistry online class, in which I'll be touching on the topic of acids and bases with reference to IB past. Hope you all enjoy that. The question we're going to cover is from a 2008 past paper, paper 2, and reads as follows. Lactic acid is a weak monoprotic acid with this Ka value, and we are asked to calculate the proton concentration of a 0.25 mol dm cube solution of lactic acid. Before we jump into the question, we are going to recap on three aspects of acid and bases. Firstly, definition of acids. Secondly, difference between strong and weak acids. And thirdly, how to calculate the strength of different acids. So let's first touch on the definition. What do we have? We firstly have Arrhenius and Bronsted-Lowry and Lewis. These are three definitions for acids, right? What does Arrhenius do? Arrhenius acid increases the proton concentration of a solution. That's what Arrhenius does. Bronsted-Lowry or Bronsted-Lowry acid is defined as a proton donor. So proton donor. And then we have Lewis acid that acts as an electron pair acceptor. Just to name out some acids, we have what? We have hydrochloric acid, sulfuric acid, ethanoic acid, which is also known as vinegar in kitchen. And let's start with this. We can drink vinegar, right? But if we try to drink hydrochloric acid, that's not going to go down so well. Why? Because what? Because hydrochloric acid is a strong acid. So let's look at what a strong acid is. So if we take the Bronsted-Lowry definition of acid, what's going to happen is that HCl is going to react with water to give out a proton to the water, resulting in a Cl minus and hydroxonium ion, which is basically what? Which is basically the proton. The reaction equation above should look quite familiar, but what about ethanoic acid? Well, ethanoic acid, CH3COOH, should react with H2O to give CH3COO minus and H3O. A few difference to note is that instead of a straight forward reaction sign, we have an equilibrium, i.e. reversible reaction sign, because unlike strong acid that undergoes full dissociation, we only have partial dissociation as weak acid. Let's add some terminology here. So we would call this species what? We would call that conjugate base. Because that will, in reverse reaction, associate with a proton to become the original acid. you should already be thinking that depending on the amount of dissociation, depending on the degree of the equilibrium constant, the strength of weak acids should change, because different weak acids have different acidity. And this should be displayed as the fraction of amount of products over amount of reactants, which should be written as the concentration of conjugate base multiplied by the concentration of proton divided by the concentration of the acid multiplied by the concentration of water. Let's draw a line here. There are two things to note here though. First thing to note is that since this is a weak acid, by definition there's only a small amount of acid dissociating, which means the concentration of water will be very, very high. So in fact, we need to omit the water, otherwise the value of this fraction will be too high. So let's delete that. And secondly, we need to note that the concentration of conjugate base and the proton H3O plus, the concentration of these two species should equal in the case of ethanoic acid. And therefore we are able to write this again in a new way as concentration of H3O plus over concentration of the acid. And going back to the original idea, we're saying that this is a, oops, forgot to add the square sign. Going back to the original idea, this equation represents the acidity, how much, the degree of dissociation going on from the acid, and we call this Ka, the acid dissociation constant. Acid dissociation constant. Acid dissociation constant. All right, so we can directly apply this knowledge to our question. Let's add in the numbers. Ka equals 1.4 times 10 to the power of minus 4, and we say Ka is that, and the concentration of our lactic acid is that. So all we have to do is replace our equation with these values. 1.4, so that is 0.00014 equals x squared over 0.25. If we take 0.25 to the left side, x squared is equal to, if I put the number into calculator, it equals 0.00035. And if we square root this number, we are going to end up with 0.005916. And then if we put this into three significant figures, it's going to be 0.005951, which is 5.91 times 10 to the power of minus 3 mole dm cube. So that's the concentration of proton from our question. So that was a brief introduction to my IV chemistry online class. Hope everybody enjoyed that and look forward to seeing you all.